controlled flow of electrons, making possible laptops, phones, cars, and many more. Batteries, just like everything else in life, is just chemistry raised to the power of awesome. The kind of chemistry that happens inside of a battery is called electrochemistry because it involves reactions that produce or consume free electrons. Particularly, they are redox reactions, the ones where electrons are exchanged. When the flow of electrons in these kinds of reactions are sent through a conductor, like a piece of metal, it can be used to do all sorts of work. The work that can be done depends on how strong the push or pull on electrons is between the two reactants. This is the reaction's electrical potential, or known as voltage. Basically, if the voltage is high, each electron can do a lot more work than if the voltage is low. Many of the things we do in life are based on a simple premise. Putting a device between two halves of such a reaction, the half that donates electrons and the half that accepts them. By harnessing that energy, a lot of things we do are made possible. Part of what makes redox so powerful is that they are complicated. Because each reaction, there's at least two things going on. There's a part in the reaction where the electrons are being released and the part where they are eagerly demanded. So when we do electrochemistry, we usually put in the term half reactions. Let's start with a typical redox reaction that happens inside an alkaline battery.
Elemental zinc is going to react with manganese dioxide, also known as manganese 4 oxide, to produce manganese 3 oxide and zinc oxide. When you break this down into half reactions, first you have elemental zinc with an oxidation number of 0 being oxidized to zinc 2 ion. At the same time, manganese 4 is being reduced to manganese 3. When we balance the half reactions, we see that 2 electrons are released during the oxidation of each zinc atom, and 1 electron is consumed by each manganese 4 atom.
So batteries are designed to harness that energy by isolating half reactions from each other. This allows excess electrons to build up in the negative terminal called the cathode, while an electron vacuum of sorts occurs in the positive terminal or the anode. Electrons can then cross from one half reaction to the other only when we connect the cathode and the anode via conductors. In these batteries, the zinc is in the center surrounded by a layer of cellulose that allows ions to pass through. The manganese oxide is in the outer layer that surrounds the zinc core, but the cellulose barrier does not allow the zinc and manganese to mix. Alkaline batteries are a type of galvanic cell, which is an apparatus that generates electrical energy from redox reactions. Electroplating is done by immersing an object in a solution that contains an excess of ions of the coating metal. A bar of the coating metal, like chromium, is used as the anode, and the item to be plated or the ion bumper acts as the cathode. When an electric current is applied, redox reaction occurs in the solution, and the atoms of the coating metal are deposited on the cathode. This is essentially the opposite of a galvanic cell, known as an electrolytic cell. An electrolytic cell performs electrolysis, which uses electricity to do the breaking part. In this case, molecules of a solution are being broken down so that the metal atoms can be deposited on the surface.